Last video we learned how to draw Lewis structures for basic molecules, and in this video we're going to add a couple little things to that. We're going to talk about something called coordinate covalent bonding, as well as the formation of polyatomic ions, and introduce resonance as well. So a coordinate covalent bond is kind of like a last resort. It's something that you kind of do when you can't get the molecule to come together any other way, because typically when you're forming a bond you have one electron from each atom pairing up to form that bond. In a coordinate covalent bond, both of the electrons in a bond come from a single atom. So it's kind of different than what we've done before. And an example where this occurs would be the molecule carbon monoxide, which exists. So if you go to draw the Lewis structure, you have 4 dots around carbon, and you have 6 dots around oxygen. 2 unshared pairs would be on the oxygen, leaving 2 dots available for bonding. If you connect the oxygen's lonely dots, what you end up with is a structure like this, where you have 2 bonds, and then you have 2 extra electrons on carbon, and then you have 2 unshared pairs on oxygen. At that point, you don't have a full octet completed for carbon. You would only have 2, 4, 6 electrons around it. So what's going to happen is oxygen is going to contribute an unshared pair into a third bond, which is a coordinate covalent bond, because both electrons would come from a single atom. Once that occurs, now both atoms have a full octet completed and are considered to be stable. So that black line shown here is the coordinate covalent bond that results from the electrons coming from oxygen exclusively and being shared between the 2 atoms. Another thing I want to introduce is the concept of polyatomic ions. So we learned about what they are in last unit. They're a group of atoms that are covalently bound that have a charge. In order to get a charge, they have to either gain or lose electrons. So most of them are negative, and we'll go over the one positive one as well today. But let's look at carbonate. So carbonate, CO3, has a -2 charge, which means it's gained 2 electrons. So if we go to draw the initial Lewis structure, you would have carbon with its 4 lonely dots, the oxygen, which would have 6, and then the other oxygen, they would all have 6 in the oxygens. But since it has a -2 charge, that means it's picked up 2 electrons. So between carbon and oxygen, the one that has the higher electron affinity value would be the oxygen, meaning it's more likely to gain an electron. So 2 of the oxygen atoms would pick up an electron, which I indicate here with the black dots. That results in an unshared pair where there was originally a single electron ready to bond. So now, when you look at it, the oxygens that gain the electron would only have 1 lonely dot available for bonding. So in this case, when we connect them all, you can see that it works to form a molecule that looks like this, where you have a double bond to one of the oxygens and then 2 single bonds. And the single bond oxygens have gained an electron, so they have a negative charge, thus resulting in the structure of carbonate. One interesting thing about this is I picked this oxygen and this oxygen. It didn't have to be those 2. It could have been these 2, could have been these 2. And in fact, all of those conditions would be equally probable. And for that reason, this molecule exhibits something called resonance, which allows the electrons to move between equivalently bonded atom pairs. So like, this is carbon oxygen, carbon oxygen, carbon oxygen, and there's nothing else sticking off of any of the oxygens. So all of those bonds would be considered, or bonding pairs would be considered equivalent. So what can happen is the double bond can actually move between those bonds. So you could end up with the double bond going from here, in this case, to another oxygen. It could also go to the other oxygen. And all 3 of these structures are equally favorable, and this is what we mean when we say the term resonance. So it adds an element of stability to the molecule as the electrons move around. Alright, so resonance, polyatomic ion, you have to include the extra electrons. Now, the one positive polyatomic ion that we had to learn about was ammonium. Ammonium is NH4 with a +1 charge. So what that means is that one of the atoms has lost an electron. When you draw your initial Lewis structure, you would have each hydrogen has 1 dot on it, because it's in the first group, and it only needs 2 to be complete. The nitrogen would then have 5. So if you draw that out, the nitrogen could really only bond to 3 hydrogen atoms, which is what ammonia is. But if you're looking at these 2 atoms, the one that's more likely to lose an electron would be hydrogen, because it's less electronegative, and it has a lower ionization energy. It's more likely to lose that electron. So when it does that, it becomes positively charged, and it becomes pretty attractive to that unshared pair of electrons on the nitrogen. So what can happen is this polyatomic ion forms a coordinate covalent bond between the nitrogen and hydrogen, where both electrons are going to come from the nitrogen, as hydrogen doesn't have one anymore. So that bond forms, and you end up with this resulting ammonium ion, where I showed the coordinate covalent bond in black, and this whole ion has an overall charge of +1. So we went over coordinate covalent bonds, polyatomic ions with coordinate covalent bonds, and we introduced the topic of resonance, which there's another video that goes into that in a little bit more detail.